Okay, hey Ellie, we are on example 3. This is 4, I believe. Yep. And we've been talking about common log. So they will use that terminology. They'll call it a common log. What is a common log?
A log that's common.
A log that's common in your calculator. It's log base 10. Right? Because that's the common one that's in your calculator. We can do log base 2 and log base 7 and log base other things, but the most common one is log base 10 because that's what your calculator thinks in, okay? And so that's what we've been doing mostly so far. I'm going to write this down. pH, this is just from the front side. You don't necessarily have to write this down, is negative log of the H3O plus that little guy, whatever that's called. That's hydronium. The hydronium hydronium ion. Okay, and so they don't have a base on that log, but we know that it's base 10, right? Okay, so that's how we calculate pH. They gave it to us where we plugged stuff in here and we calculate it, and they gave it to us where we plugged stuff in here and we work backwards, okay? And so that's what this next problem is going to be like. Wetlands are classified as bogs, fens, marshes, and swamps. You do have a homework assignment that's asking about the same stuff, like is it a swamp, is it a marsh, is it whatever, right? Okay, so you'll have to come back to example 3, and I think it says that on your homework assignment. Based on pH values, the pH value between 6 and 7.5 is a wetland, is a rich fen. 6.0 to 7.5, that's what that's considered, is a rich fen, okay? It is considered a poor fen. I have no idea what this is. If it's between 3 and 6, that would be acidic, right? Like we're talking about, like if it's good for producing things, I guess. Okay, if the pH is less than 3, it can't be anything lower than 1, right? Can you have a pH go lower than 1? It goes 1 to 14.
Yes.
Can you have a pH of 0?
It's a stupid rule, and it's something we got into early on in Chem too.
Okay.
It's like very, very specific.
Okay, so I'm going to say up to 3. 3 or less is called a bog. That is very, very acidic. Okay, now they're just going to give you the information and say which wetland is this. Okay, so if it has 6.3 times 10 to the negative 5, how would this wetland be classified? So we do negative log of that number, right? And you can just type this into your calculator. Yesterday we broke this apart because multiply means add. So we've got log base 10 of negative log base 10 of 6.3 plus negative log base 10 of 10 to the negative 5th power, right? So we can do that if you don't want to type this in. Do you know what this comes out to be? The log base 10 and 10 is going to cancel, right? So that would end up being minus a negative 5. So that would end up being plus 5. So all you have to do is take negative log base 10 of 6.3 and then add 5 to it. What's this come out to be? Somebody have that?
0.372.
Is it negative 0.372? Positive, if you put the negative in front of it? Yeah, it's positive 0.372. Okay? So this guy would be 5.372. Did you?
Not that.
Not that?
Then again, I did it the way we did in chemistry.
No. Did you type it in as the standard, as the
Yeah.
scientific notation? And we didn't get the same number? Log, oh gosh, you gotta turn it.
4.2.
Negative log of 6.3.
Of 6.3, I get negative 0.7.
Yeah, that's what I got. Okay, let me erase this.
Yeah, so 4.2, which is what I got, is accurate.
Yeah, okay, so I got, yeah. So this number should be negative 0.7993. Yep. And then if I add that to 5, so 4.2007.
5.9.
Yeah. 4.2007 or whatever, right? So what is he?
A poor fen.
He's a poor fen. I don't know what that means, but that's how you classify his wetland area.
The difference is
poor
fens are fed by like fresh water, like
Okay.
rivers and stuff, so they're really high in minerals,
Okay.
and they're not very acidic.
Okay.
And a bog is fed by rainwater, so it's
Very
really
acidic.
and has like no minerals in it.
Gotcha. Okay. Nice.
How did you
Okay.
know all this?
I don't know.
But a rich fen would be better than a poor fen because they would be mineral rich and it would be
Incredibly
less
mineral
acidic.
rich, yeah.
Yes.
Do you
Nice.
suggest-
Cool. Interesting.
No.
Connor, what are you doing with your life? You need to go in and be like a science teacher.
I know so much stupid stuff.
I know, but you should go in and like be Mr. Remuth.
You
Yeah,
should.
Connor,
They'll hire you tomorrow. You graduate, you could be, I don't know how that works, but
Connor, you pretty much taught in chemistry.
right, no kidding. Yeah.
You made
You
it
should,
back.
seriously. Ah, you can come back and work with me. You can be my coworker then. That'd be awesome.
Like, yeah, I don't know about that one.
Yeah. Yeah. So anyway, whatever. Okay. The loudness of sound. So we talked about loudness, how that is a log also. We first assign, a loudness of sound is measured in decibels. So this is loudness. D stands for loudness. I is intensity of the sound. Whatever sound that we are talking about. And I naught is the intensity of like that's like the lowest sound threshold, right? So I'm just gonna to a very faint threshold sound.
We did this in physics.
Yeah. Okay, it is the threshold sound. So find the decibel rating of a sound with an intensity of this times I naught, okay? We don't even know what the threshold for sound is. You guys probably have a better threshold for sound than I do because my ears are older, right? So like your minimum intensity would probably be lower than mine because I can't hear until it's an intensity of so much because I'm old, right? Okay, so we don't even know what this number is, and it probably depends on each individual person. But here's what we have, okay? If I plug in that thing in for I naught, I have 10,000 I naught. If I'm plugging this guy in for I, right? But I still have I naught on the bottom. It doesn't matter what that I naught is because it's going to cancel, right? So they're saying it's 10,000 times whatever your ear can hear. That's what I naught is. 10,000 times whatever your ear can hear. Okay? So we're really doing 10 log of 10,000 is really what we're doing, right? Okay? But this guy, if I'm just looking at this part right here, do you know what this part right here is? What is 10? What? What? Oh my gosh, quit that. Ah, I heard that one.
Is it
40.
I got 40.
like
You got 40. Okay, so do you know why it's 40? This guy right here, just look at this piece. 10 to the fourth power is 10,000. So this number right here is 4, right? And then 4 times 10. So this has a loudness of 40 decibels, right?
That hurts.
How does it hurt?
It like
What?
hurt my brain.
Ah, I can hear that.
That one's not a good one.
you can
I
hear
think
the
10.
other ones.
That's the only one.
So
That one and the first one. That's the only one I could hear. Heard that? Huh? Interesting. I hear that. Play a light one.
Can't hear this?
I can't hear it. I can't. Can you hear it?
Yeah.
I can't hear it. Ah, I'm going deaf. It's
Can you hear
terrible. I hear that one.
Okay. Now?
I can't
Okay,
hear
so
it.
somewhere
You
in the
can't.
1500s. Well, 15,000s. Sorry, you fall off.
I fall off at the 50. I hear that. Woo! I wonder if Ellie can hear this over the computer screen. Interesting.
Generator?
Weird. I don't know. I'm getting old and my ears are just not. I do know that I have some hearing loss in this ear. And I've like the hypochondriac in me is convinced that like I have like a brain tumor or something that's causing this ear to go deaf. You know, like that's what I sit and keeps me awake at night, you know. Stupid. Anyway, whatever.
There was one time where I was panicking so much because I had eye pressure and I didn't go to sleep at all that night.
Nah.
It really does sound like when the 3D printer moves.
Does your eye
Yeah.
twitch over?
Yeah. What?
Your
Does my
just,
eye
like,
twitch?
twitches? Yeah.
Yeah, it's because you're tired. Yeah.
Oh.
Yeah. It's because you're like your muscle is whatever. Your muscle is your fatigued. Yeah. Okay. Next thing, natural log. So we just had common log, and I just wrote that at the top. The common log is log base.
Oh. Matt. Yeah, Matt also.
I don't hear nothing.
What is it at?
Is he
right
still
now?
doing it? I don't even know.
15,500. Aiden, can you hear it?
Yeah.
I cannot hear nothing.
Is that the lowest it goes?
No, it goes way higher.
This doesn't damage your ear at all.
Yeah.
You can't hear it? Wow. You can't hear this at all?
You can hear it?
No.
Yeah.
I can.
Huh. I can't hear nothing.
You hear this one?
Yeah.
I went higher.
How did I not hear the other one?
I don't know.
I can hear that one.
Oh, I hear that one.
I went way down.
Oh, I really hear that one. Weird. Okay, all right. Common log, natural log. Common log is log base 10.
Shut that off.
Natural, yeah, don't leave that on the whole time. You're going to deafen me. Natural log.
Hurt your ears there.
Natural log is log natural, or ln, and ln is log base e. Do you remember talking about e when we did PERT? E is 2.72818, blah, 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 and he goes on forever, right? It's that number that occurs in compounding interest, right? So since e is such a special number, he has a special name for log of e, and it is ln.
It is not on. It is on.
Now, ln and e are inverses of each other. Kind of like, what's the inverse of log base 10? 10 to the x power, right. So this is the exponential function. So those two things cancel each other out. Ln and e cancel each other out. So ln is natural log base e. Killing me, kid. All right, these three we got to type in our calculator, except the first one you don't have to type in because it is just 3, right? Ln and e cancel if they're right next to each other. It's 3. But ln of 142.
Oh my goodness. 4.9558.
Perfect. Okay, ln of that is probably going to be a negative, because when you're going decimals, you got to have a negative exponent.
Negative 5.1444.
Okay, there we go. Typing them in. All right, good. Example 6. Geologists sometimes measure the age of rocks by using atomic clocks. By measuring the amounts of argon and potassium in a rock, it is possible to find the age of the specimen. That's very interesting. Oh, I hear that. The time.
The type of wave. Oh.
Okay, we have two variables going on in here. This is time in years. Okay, and the two variables are A, which stands for argon, and K, which stands for
Kryptonite.
potassium,
Oh yeah.
Yeah, guys.
That
right?
confuses me.
Potassium is K. Okay. So the amount of argon, the amount of potassium, they measure it, they plug it into this formula, and they can tell how long this thing's been dead. Not dead, because it's a rock. It's been dead. Okay. How old is a rock in which A is 0 and K is greater than 0? What?
So can you just put 0 over 1?
What?
Connor, I'm kidding.
Confusion.
This is a different type, guys.
Confusion. How old is a rock? Which now K? The reason why they say K is greater than 0 is K can't be 0. You know why? You can't divide by 0. So let's just we'll plug in 0 for A, right? And let's just plug in a number for K. What number?
It really doesn't matter.
1. It doesn't matter because 0 divided by anything is going to be 0, right? Okay. All right. Now we have 8.33 times 0 is 0. And ln of 1 plus 0 is just ln of 1 on the top here, right? Okay, so here's what I want you to do. I want you to take, oh my gosh, 1.266. What's ln of 1, by the way? Type in, what's ln of 1?
0.
Ln of 1 is 0. Ln of 2?
Everything's gonna be 0.
Ln of 2, we don't care, is a number, right? What's 0 divided by a number? This whole thing is going to be 0. And what's 0 times this guy? 0, right? Okay, so how old is a rock in which the argon level is 0 and K is anything else?
It's dead.
It's
It's extra dead.
it's not extra dead.
It's 0.
It's brand new. It's 0 years old. T is 0.
Hear this?
Yes.
Yeah?
Can?
T is 0 years.
Roger, can you hear that?
I cannot hear nothing.
I can't hear you.
No.
I can hear that.
Don't scare me.
Now?
I feel like
Nope,
after having
nothing.
kids, you just kind of like.
Your just body deteriorates and everything. Or it could be the fact that I'm old. So I'm gonna be 35 this year.
This,
My
does this
mom's
actually
40,
bother you?
She'll be 41 in August.
Like,
My
seriously?
mom's
Like, my
gonna be
brain is
50
like-
soon. My dad's
hurt.
already.
I'm used to this sound for some
Crazy.
It hurts
reason.
my ears, but I can't hear anything.
Crazy.
It hurts my head.
I'll stop.
It makes me want to like throw up.
All right, here we go. B, the ratio of A to K for a sample of granite is 0.212. What does that mean?
It equals 0.212.
Yeah, A over K equals 0.212. So I can take and plug that whole thing in for A over K, A over K, right? So here we go, 0.212. All right, I'm gonna do this part. 0.212 times 8.33. 0.212 times 8. 8.33. Oh, shoot.
1.76596.
Yes, and then I'm going to add 1 to that. So
That's a big number.
2.76596, whatever, okay? So I'm doing ln of that number, ln of that number, divided by ln of 2. Okay, so for this whole thing right here, I got 1.4678. Something like that. I'm going to take that times 1.26 times 10 to the 9th power. How many zeros will that have on the end of it?
9, 8,
7.
7,
7.
Because
right? Because there's 2 decimals here. 1, 2, 3, 4, 5, 6, 7. It has been around for this many.
1.8 trillion.
I did it right.
1.8 trillion years. Holy moly. That's what this is. Is the sample to the nearest hundredth of a billion years.
Oh, yeah, I did it right.
Oh, how old is the sample to the nearest hundredth of a billion years? Which one's billion? Which number up here is the billion spot?
The 8. I mean.
Actually, that's not trillion, that's billion,
Yes, that is billion.
right? This is billion right here. When
Oh,
they
yeah, I
say
did it.
hundredth of a billion,
I did the wrong math.
Hundredth.
Mine's in scientific notation.
hundredth of a billion,
1.85 billion.
this is the hundredth of a billion would be that guy, right?
Yeah.
Would be the 4. So 1.85 billion. Yeah.
So
1.85 billion years. Yep. Okay?
For what, Saturday?
Good. Because when you put it in decimal form, this is the 10th place, this is the 100th place, right? Okay. All right.
No.
Let's stop there.
woohoo.
Let's stop there. Then we'll have 3 examples to do on Monday. Yeah? All right. You can start the homework. Yeah, some of it's just like type this junk into your calculator. All right. Bye, Ellie.